Hi, Annalisa. Hi, everybody. Good morning. I'm going to talk to you today about the diagonals of polygons. And here I have a dodecagon. A dodecagon has 12 sides, 12 vertices, 12 sides. I'll go around thinking n is equal to 12. And questions you're going to be able to answer quickly in a moment would be, how many diagonals can you draw in a dodecagon? How many diagonals could I draw on this figure? We'll do that with a decagon too. But first, let's start with some ideas that are pretty simple. We ought to define what is a diagonal in the first place. So I drew a square. And a diagonal, by definition, goes from a vertex of a polygon to a non-adjacent vertex. I can't go from A to B, that would be a side. I can't go from A to D, that would just be a side. I can't go from A to A, but I can go from A to C, and that would be a diagonal. From a vertex to a non-adjacent vertex. And I can draw one diagonal from vertex B as well, to a non-adjacent vertex. When you get to vertex C, well, that diagonal's already been drawn. So let me just answer these questions about this polygon. When I got a square, and DSV is going to stand for how many diagonals from a single vertex. Diagonals from a single vertex. From this vertex A, I can only show one diagonal. From B, I can show one diagonal. C, I can only show one diagonal, and it had already been shown, as a matter of fact. And the total number of diagonals in a four-sided figure with n is equal to 4. Now, when I say n is equal to 4, you've got to be thinking that's 4 sides, but it's also 4 vertices. How many diagonals can you draw on this rectangle from 4 sides? And then again, just from this vertex, I can draw one. From this vertex, I can draw another. And I can't draw any more. So total number of diagonals is just 2. Let's play with a pentagon. And the first question I'd like to think is, how many diagonals can you draw from a single vertex? That's what I mean by DSV. How many diagonals from a single vertex when n is equal to 5? 5 sides, 5 vertices. Well, I can't go from Q to itself. I can't go from Q to P. I can't go from Q to R. But I can go everywhere else. So I can do 2 diagonals from a single vertex. When I go to point R, I can also do 2 diagonals. When I go to point S, I can just do 1 diagonal, because the other one's already shown. Every vertex gets 2 diagonals, but I don't want to count them twice. And those those diagonals from vertex T are already shown. So let me just think. How many diagonals could I draw from a single vertex? Was 2. I could draw 2 diagonals from every vertex, and I got 5 vertices, but I don't want to count anything twice, so I ought to divide that by 2. And the total number of diagonals is just 5. We won't count them anymore, but there's 1, and there's 2, and there's 3, and there's 4, and there's 5, and yeah, so we got 5 diagonals in that figure. How about a hexagon? Let's do the diagonals from a single vertex, and then the total number of diagonals in a hexagon. And you're thinking already, well, that means n is equal to 6. It's got 6 sides, 6 angles. How many diagonals from a single vertex? That's what I always want to think of first. And I got to leave 3 of them out. I can't go from W to W, I can't go from W to V, I can't go from W to X, but I can go every other vertex. I can show 3 diagonals from that vertex. And I can show 3 from X, and 3 from Y, and 3 from Z, and 3 from U, 3 from every vertex. Makes me think I could do 3 vertices, 3 diagonals from every vertex, and I got 6 vertices. But you know I'm going to be counting everything twice, huh? So I don't want to do that. How many diagonals from a single vertex is 3? When n is equal to 6. And the total number of diagonals? Looks like I'm going to get 9 of them. Just 3 times 6 gave me 18 and divided by 2. 3 from this vertex. Let me just do that one time. 3 from that vertex. This will be 4, 5, 6, 7, 8, and the only other diagonal I can show goes from here to there. And I can show 9 diagonals in this 6-sided figure. How about an octagon? Let's play with an octagon. I want to know how many diagonals from a single vertex. I want to know the total number of diagonals that can be drawn. Total diagonals. And you're thinking, well, n is equal to 8. That would be a formula for this, huh? From vertex A, if I showed every diagonal that I couldn't go to A, or A to B, or A to H. I'd have to leave those 3 out, so I guess I can get 5 diagonals from a single vertex. How many diagonals can I draw altogether? 5 diagonals from a single vertex, and I have 8 vertices, but that would have everything being counted twice. 5 diagonals from a single vertex, 8 vertices, but don't count anything twice. I have to divide that by 2, so I have 40 divided by 2. And in an octagon, you can show 20 diagonals. I'm sure of it. Now, let's take a look here with a decagon. N is equal to 10. How many diagonals from a single vertex? Well, if I chose that vertex, I'll call that vertex A. Go around there. Let me fix this up and see how many diagonals I can draw from a single vertex. I could draw 7 diagonals from a single vertex in this 10-sided figure. 7 diagonals from a single vertex. And so what's the total number of diagonals that I could draw? That would be predicting that. 7 from every vertex. I have 10 vertices. But that would call E a diagonal, and later when I get to vertex E and start showing diagonals, I call EA at another diagonal. I don't want to count that twice. I got to divide that by 2. So it looks like I got 35 total diagonals there. And so I'm here to tell you, and I don't really want to count them, but here I did show all the diagonals possible in this decagon, and I'm thinking there's 35 of them. But then what about this dodecagon? 12 sides, best polygon I can draw. Here it has all the diagonals that can have. Every one I could show. How many diagonals could I show from a single vertex? What's the DSV for this polygon? From vertex A, I can't go to from A to A, nor from A to B, nor from A to K. I had to leave those 3 out. So from vertex A, I could show 9 diagonals from a single vertex. So what about that total? 9 diagonals from every vertex. I have 12 vertices. I don't want to count anything twice. So what I really got there is I can do this division and get 6, and 9 times 6 is 54. So I'm telling you, the total number of diagonals is 54 in this 12-sided figure. But what you want to carry with you is a formula for this, huh? So in a polygon, diagonals from a single vertex, if the n is the number of sides, how many diagonals would we have from a single vertex? N minus 3. And what is the total number of diagonals? It would be how many diagonals from a single vertex times how many vertices you got. Don't count anything twice. So using these few formulas, you ought to be able to figure out anything you need to know about diagonals. I'm going to make another little video about the angles of a polygon and how to find the sum of the interior angles of a polygon and predict each one. You'll need to see that video too before you can get this homework done. See you soon. We'll talk about that right away.